So, to begin, vacuum measurement. The reason we're offering this is because we find that there's a lot of misunderstandings around vacuum measurement. I personally used to work in the service department here at Testo for 2.5 years, taken hundreds of vacuum calls. The vast majority of these are things that we were able to determine that can be resolved by the customer. There were misunderstandings. There was issues with setup. There was things where there was some simple problem solving where customers were able to do some cleaning or some something fairly simple to get themselves back up and going. The hope is that we can pass that knowledge on to you guys, and you'll get some better understanding of common problems and how to problem solve these and make sure you have the most uptime as much as possible. Without further ado, let's get started. So as I said at the beginning there, goal of this is to talk about best practices when measuring vacuum and give you some problem solving tips. Course will be around Testo vacuum probes, but a lot of what I'm talking about does cover other brands as well. So Testo uses Prani sensors to measure vacuum. I'm not going to go into how Prani sensors work, but what's important to remember here is that they are highly accurate, they are robust, and more importantly, in terms of this session, they are something that the end user can clean. So I just want to cover some terminology so we're all on the same page here. When I talk about vacuum target, it is the vacuum pressure that you're trying to get your vacuum gauge and your system all hooked up to before you isolate from your vacuum. While when I talk about maximum decay target, that is the vacuum pressure when after isolating, it's always going to go up a little bit. Your maximum decay target is your limit to where you say, okay, that is acceptable. Any further beyond that, and it is a fail. So the primary purpose of vacuuming down air conditioning systems and refrigeration systems is to remove the water from the system. Vacuum pressures below 15,000 micron will cause the water to start to boil at room temperature. Now, your targets will be much lower than this. Your air conditioning manufacturers set your targets, and the reason they do that is so to ensure that all of the water, every single drop, has been evacuated and boiled off in the system. Vacuum pressure checks are also used to look for leaks, but their primary purpose is to be removing water. Now, I really wish I had a chance to do this video personally myself, but I've taken a video from Wolf Science on YouTube on showing how water boils under vacuum. It's really good, so I just wanted to give credit for him for this video.
I just love it when science mimics magic. What I've got here is a beaker of regular old tap water. I'm going to put it inside the vacuum chamber. We turn on the vacuum and watch what happens. So we've got the water boiling inside the vacuum, but take a look at this. That's magical on its own, but when I release the pressure, the water is not hot at all. It's still room temperature. By lowering the vapor pressure of the air inside the vacuum chamber, I could allow the water to boil. That's why water boils easier when you get up to elevation. It boils at a lower temperature. And so a 3-minute egg in the mountains isn't really a 3-minute egg. It's more like a 5-minute egg. I love science. Have a great day.
Okay, before you even go out to do to vacuum down an air conditioning refrigeration system, it is critical that you have the right tools. You'll need vacuum rated valves and hoses. Filling hoses, like what would come with, say, a refrigeration manifold, are designed purely for putting refrigerant in. They are not designed for vacuum. You do need special hoses. And even these valves on this manifold are not vacuum rated. You need special vacuum rated valves. We also recommend that you have dedicated vacuum valve because even the best valve is going to leak once you start putting a lot of refrigerant and residue through it. So you want to keep it as clean as possible. And finally, we want to make sure you got the correct size fittings. If they're not the correct size, they will leak. Now, I just want to briefly talk about a Monton's law and Charlie's law. To simplify it, the law says that if there's an increase in temperature, there's an increase in pressure. If there's a decrease in temperature, there's a decrease in pressure. From a molecular point of view, what it means is that when the temperature increases, all your molecules are moving around more and hitting off each other, increasing the pressure. And when it cools down, they stop moving around as much and it decreases your pressure. Now, this is particularly important if you're doing a test across a long period of time, because the temperatures are going to fluctuate during the day. Also be aware that barometric pressures or your atmospheric pressure will affect the vacuum reading as well. What does this all mean for you guys? What it means is that some vacuum probes have corrections all automatically built in, like the 552 here has temperature correction and atmospheric or barometric pressure readings, corrections built in. You don't need to worry about these things. While this one, the 552i, is much simpler, you would need to use a separate probe or put the readings in yourself. So if you are noticing that there is big vacuum changes and then you're also noticing there's a big temperature change, then there's a good chance that the temperature is causing your pressure changes or your vacuum readings to change. So it's a good idea to know if your vacuum gauge has corrections built in. So what I've done here is tried to boil down or simplify the four most common questions we have. Obviously, we get a lot of other questions coming in as well, but these I've really generalized them. The first one, my vacuum gauge pulls down under vacuum but leaks as soon as the vacuum gauge is isolated from vacuum. My vacuum gauge was working and suddenly stopped working mid-measurement. My vacuum gauge readings are radically jumping around. And finally, my vacuum gauge just doesn't work. It's not pulling down on vacuum. It's just not accurate. That's the most annoying one, and I've left that one to last for a reason. So my vacuum gauge pulls down under vacuum but leaks as soon as the vacuum gauge is isolated from vacuum. What does this mean? Well, what it means is that there's a good chance that your vacuum gauge is completely fine. It's not leaking from here. We've done a lot of testing here. We've purposely made these things leak, and they won't pull below 2,000 micron. So say we've got it hooked up directly to your pump, running your pump without a valve, with no valves involved, they won't pull down below 2,000 micron. So potentially there is a leak somewhere else in the system, leaky valve, leaky hose, or you just have too small a vacuum volume. Now, there's no rule for a minimum size vacuum volume, but a small air conditioner is what you really need as a minimum size for your vacuum volume. And what we've done here is I've put together the two most highly recommended setups that we find if people go this way, they don't have any issue. The top one is if you've got two service ports and you'd be putting your vacuum gauge onto one service port of your aircon. Try and keep the fittings to a minimum as possible. Avoid hoses. Just have a coupling from your or hook directly onto the service port, or just have a very short brass coupling, copper coupling. And then on your other service port, you put an isolation valve as close to the service port as possible. From that isolation valve, you run around to your vacuum pump. Okay, the idea of this is you can isolate as close to your air conditioning system as possible, so the minimum number of potential leaks, and your vacuum gauge wants to be as close to your air conditioning system as possible to give you the most accurate result. The second example here is if you only have a single service port. Now, in this situation, you're going to have, out of your service port, you're going to have a T with an isolation valve that runs off to your vacuum pump like normal. Or you can have, and from the other side, you've got the vacuum gauge hooked to the other section of the T. Alternatively, you could be using something like a core removal tool as your T instead. You might notice that there's a black valve on the bottom one. The black valve is there just to isolate the vacuum probe to pull it off. It is not there to isolate, to check to see if there's a leak. Because if you do that, there'll be too small a vacuum volume and it'll appear like a leak. You might notice that there's a manifold in this picture as well. There's no particular reason why you would actually have a manifold for your vacuum stage. But that being said, some people do want to have their manifold in there. If that is the case, open up all your valves, cap off everything that you are not using. I don't know why you do this. This is just another point that acts as a restriction point and another potential area that could leak. So some people want to have their manifolds in their vacuum setup when they're vacuuming down. So that's how we would do it. Okay. I don't have a full setup here, but off here, you've got your hose off to your air conditioning system over here, and you've got your isolation valve here. Okay. When you're isolating from your pump, okay, we already talked about the vacuum gauge being as close to your pump as possible, but when you isolate, you also need to leave the system to equalize. This is important because your vacuum, when this is open and everything is under vacuum to your vacuum pump, the vacuum at your vacuum pump is going to be higher than it is at your air conditioning system because there's more restriction by the time you get to your air conditioning system. When you isolate, everything equalizes. You need to wait for the system to equalize and stabilize before you do that test to see if the system is holding, your decay test. You can see the chart that I've done, I've taken from a vacuum probe that I was testing. Down the bottom, you can see how the more it's trying to suck the vacuum out, the longer, the harder it is to actually pull the vacuum. So it's now a curve. When we isolate, it actually temporarily goes up a little bit and then settles back down for the test. We've found that if you have a really small vacuum volume, that bump where it goes up goes quite high, it's quite large. So you need a larger vacuum volume as a ballast. So what I've got here is I've got some examples of insufficient vacuum volume. First example, and there's lots of issues with this, is people like to hook up their vacuum gauges directly to their manifolds. Lots of problems. There could be refrigerant or a little bit of moisture in your vacuum, in your manifold. It's going to end up in your vacuum gauge. It's upside down, so if there's any in the line, it's also going to, any moisture and oil in the line, it's also going to end up in there. These valves are not vacuum rated, okay? And on top of that, if you are doing this, the vacuum volume is too small if you get tempted to isolate from here. So we do not recommend that you hook them up directly to your manifold like this. The second one and the third one are quite similar situations where somebody has hooked up their vacuum probe directly to their vacuum gauge. And there's a nice, it would be open, they turn it on. Suck it down under vacuum. This one here is down to, look, it's below 15 micron at this point. It's really, really good. Then they go, and then say they've got an isolation valve in here. They then close the isolation valve and the readings, and turn off their pump, and their readings go through the roof. Too small a vacuum volume, you can't do that. When you're doing the test, don't isolate. So my vacuum gauge was working and suddenly stopped working mid-measurement. Could be a couple of things. You may, if you've overpressured, if you pressurize the system with positive pressure, pressure above room pressure, these are only rated to 5 bar above room pressure, you will destroy the sensor. But what's more likely is that you've had oil and moisture drop into your vacuum gauge and you've contaminated it. So to prevent this from occurring, position it in a way where it's upright and the moisture and oil won't naturally drop in. If it's like this, it's naturally going to drop in. If it's like this, it's not naturally going to drop in. With something like this one, the center is here, so it's fine like this. But if it's upside down for whatever reason, it's going to drop straight into the sensor. If you do contaminate them, not a problem, they can be cleaned. So with this one, just use a shredder core removal tool, or in my case, I'm just carefully using a pair of needle nose pliers to remove the shredder core. Isopropyl alcohol, pour a little bit in, cap it, tip it out. Depending how dirty it is, I'll do this a few times. Put it all back together. These seals have a lip on them, so make sure that the lip goes to the outside. If you're doing this with other brands, just contact that brand to make sure that you're using their recommended method, because there may be something different about theirs. We'll go one up later. This one here, don't have to remove a seal or the shredder core. You may notice when I'm doing this that I'm not actually pouring the isopropyl in. When you do it, please do actually pour the isopropyl alcohol in. I just don't want to make a mess. Empty it out. Do it again. You can even put these back under vacuum and they'll dry fairly quickly, or you can just let them air dry if you have the time. They're not going to start working straight away, but as soon as they dry, they'll be up and working again. So we talked about vacuum curves before when I was talking about minimum volumes and having to let the system equalize after isolating. What we have here, I've got the same graph on the left. This is a perfect system where it's a clean vacuum probe on our test bench downstairs, and it comes out nice and smooth. On the right, we've got something that's come back. It's been contaminated with a bit of moisture and oil. You can see the readings are starting to get, they're not as smooth anymore. What you can do in this situation is, I would recommend when you get a chance, give it a clean before it gets any worse. Now, there is a few other ways to get around erratic vacuum readings. Increasing the measurement cycle is one way. The Testo vacuum probes have a measurement cycle of 1 second. It just means they take a measurement every second. Increasing it is an option. I normally don't recommend it. Another option is what's called damping. This is a moving average. So what occurs is every time it takes a reading, so say the measurement cycle is 1 second, it takes that reading and it takes the last 9 seconds as well, and it averages those out and gives you the reading. Then the next measurement cycle, say the next second, it'll take the last 9 measurement cycles, and it's just a slowly moving average, and that will help smooth out your curve a little bit, but just be aware it won't fix the issue if you're having being caused by any of the other issues. We also already talked about temperature correction as well. So my vacuum gauge is not pulling down on the vacuum, it's not accurate. So this one is one which is really hard to do over the phone because there's not a lot of information here. It doesn't work. Great. Can you tell me more? Oh, it's just never worked. What's not accurate compared to something else? We need more information if we're going to help you problem solve something like this. First question I'd be asking is, was the vacuum gauge working and suddenly stopped working? If that was the case and it suddenly stopped working, that tells me that it's either going to be moisture and oil that's got in the system, or you've overpressured it. Someone's just overpressured it. Go down that path of cleaning it, making sure that someone hasn't pressurized the lines. Then retest, because you never know if there's another issue as well. But say the vacuum gauge, you've always had it and it just never worked properly. First thing you do is you simplify your system down to a vacuum gauge and a vacuum pump. No valve or anything else. We're just putting it directly on here. Unfortunately, with something like this one, you would have to use a coupling, like a copper or brass coupling. But in this one, it's easy. We just this gauge, it's easy. We just put it directly on, and we just turn it on. If it comes down, then we know that it's not the pump, it's not the vacuum gauge. It's going to be, a hose or a valve. That's where I'd be looking next. But let's just say that it doesn't come down when you hook it directly on. Make sure the seal is intact. Okay. You can buy extra seals for these, and I recommend you do. But if the seal is intact, the next thing I'd be saying is, when was the last time I changed my vacuum oil in my vacuum pump? Change your oil over, new oil, this hooked up, it's still failing. What do I do? This is the point where you contact your manufacturer or supplier and they're going to give you extra information, potentially um, tell you how to make warranty claims, etc. Now, as I said before, spares are important, especially ones that wear out. So if your probe has seals, buy spare seals. Buy some spare seals for your hoses. There's nothing worse than turns out being a leaky seal, and you have to stop your work and try and get a new one. It's going to cost you a lot of time. So just keep some spares. Okay, this is an interesting one. Seems very, very simple, but we do get the odd one where people say, I've changed the batteries and it doesn't work anymore. Okay. With this one in particular, the 552i, it's really critical that you follow the markings on the side of the battery cage and don't follow the springs and the other contacts. Just follow what the markings say. So positive goes this way, that way, and negative. Other than that, just make sure the batteries aren't flat and make sure the contacts on here that aren't covered in corrosion. Okay, but it is quite embarrassing for people if you send it in and all it turns out is that it's got the batteries are in the wrong way. So just make sure the batteries are in the right way if you're changing the batteries around. So this is just my full problem solving guide that I put together. It's far from complete, and I'm happy to take any criticism or any ways that it can be improved, but it is there available for you to use. On top of that, I'm happy to send you any of this information as well. Again, here's the cleaning method we went through on how to clean the Testo vacuum gauges. Again, if you're using different vacuum probes and gauges, contact a supplier. You might find that there's a very similar method, but there might be a few tweaks here and there. So these smart probes, I put something together just briefly because they actually have indicator lights on them, green, red, yellow. So this is just a slide to give you some idea. It really is just a follow-up to the battery slide that we talked about earlier. And finally, I get the odd question around how I'm having issues connecting my 552i vacuum probe to my manifold. So again, here's a little bit of problem solving.